what I did is notice that I changed the distance so that the values are 15s and 25s versus 15.00s and 25.00s. SPSS did not like the fact that there were zeros there.
So just backspace the zeros out?
Get rid of the zeros and the periods. So, and that's also because, and I'm sorry, what?
Don't hit X, get out of there. Don't do it. So, no decimals.
That's right. If you have a
Oh, God.
nominal or groups that you want to compare and they're numerical, like we have here, 15 and 25, if you enter them as string, they'll probably appear this way, but they did not convert. When we converted to string and nominal, they did not convert. But now they're in their string or nominal form.
See where it says decimals? That first one should be 0. Should they all be 0? Or
You mean
just
0?
the nominal one should be 0, right? Decimals?
Oh, those others can be decimals.
Okay.
The plants can be decimals.
Yeah, so just the-
But the distance, which is our string variable, our nominal variable, our different categories or groups, those need to have those sorts of designations. So now we're going to try running the t-test. So I'm going to go to Analyze, and I'm going to go to Compare Means, and I'm going to go to the Independent Samples t-test. And now I'm going to take rhizophytic algae and stick it in the test variable, which is your y variable. And distance is going to be your x variable. And I'm going to stick that into the grouping variable. And when we stick distance into the grouping variable, you then can click on Define Groups. And another box will come up and you'll have to enter your two groups. So 15 and then 20. And then you would press 25. Oh my goodness, thank you. Then we press Continue. And then we press OK. And now we have results. Thank goodness. Okay. So an output box will come up, which is separate from your data view, and it will show you results for the t-test. Number 1, the results provided include, notice, the mean, as well as the standard error of the mean, which is the standard error. So you don't even have to calculate these things in Excel, really. You can just calculate them here in a t-test. So yes, very convenient. And notice our means are 0 and 0.1667. Okay, the next thing that we have to do is look at results from not just the t-test, but an assumption that is supposed to be met for you to run the t-test. So there are various assumptions that are supposed to be met, and I'm not going to go in depth into this because that's kind of a higher level calculus class as far as I'm concerned. But one of them is this equality of variance tests. So if you look at the independent samples test, and if you look at the first column, it says rhizoalgae, and then it says equal variance is assumed, and then equal variance is not assumed. And then we go ahead and we look at the next column, and it says F. Right, that is the test statistic for this Levene's test for equality of variances, which you see above. And then we have SIG, which represents the p-value. The p-value can be used to determine whether there is a significant difference. In this particular case, our p-value is 0.016. So you need to go ahead and look at that p-value and compare it to alpha, which is 0.05. And in this particular case, because the p-value is equal to or lower than alpha, which is 0.05, what that means is, in this case, we do not meet the assumption of equal variances. And what that is going to go ahead and indicate to us is whether or not we are going to use the equal variance as assumed or the equal variances not assumed row. Because of the fact that we have this really low p-value, lower than 0.05, that's saying that we do not have equal variances. So in this case, for our t-test, we're going to use the bottom row, equal variances not assumed. So then we move over to the right on the table, and it lists our t-value. Notice it says t-test for equality of means. So t-test for equality of means, this is where we're comparing our means for our two groups, 15 and 25. Our t-value is our test statistic, and here it says our t-value is -1. Does everyone see where it says t of -1? And it says that it's -1 regardless of which row you're using. They're both a -1. But it in fact gives you different p-values. The sig value is your p-value. All right, so wherever it says sig, that's a p-value. And in this case, we are looking at the sig value of 0.423. We're looking at that bottom row because we didn't have equal variances. And what that means is that that p-value of 0.423, it's a lot higher than 0.05, right? If your p-value is higher than 0.05, there's no difference between the groups. If your p-value is equal to 0.05 or less, that means you have a difference between two groups. So here, with this 0.423, there's no difference. So we're looking at rhizophytic algae. We're looking to see if there's a difference in the percentage of rhizophytic algae between 15 and 25, and there was no difference between the two. So that's one less graph you have to make. Okay, let us try the next analysis. All right, so I'm going to go back to my data. And now we're going to do distance and seagrass. And I'm willing to bet there's a difference here, but I could be wrong. And that's just, again, by looking at the data. So in this case, I am going to go to Analyze, Compare Means, Independent Samples t-test. In this case, I'm going to leave my groups of 15 and 25, but I'm going to take that rhizophytic algae, I'm going to click on it, I'm going to get rid of it, send it back to where it came from, and I'm going to take my seagrass, and I'm going to bring it over to the right. And then I'm going to press OK. Ba-ba! Now we should have results for seagrass. Does everyone have results for seagrass that they're looking at?
Yes.
Okay.
She's getting there.
Okay. Look at these means, very different. For 15, we had only 33% seagrass, and for 25 meters, 66% seagrass. I'm willing to bet there's a difference, but there's always a chance there's not. We also have a very low sample size, which interferes with our ability to detect differences. So the first thing that we want to look at, again, is that equality of variance test. And so for F, we have 1.691, and for our p-value, 0.263. With a value of 0.263, do we have equal variances or not?
We do.
We do. We have equal variances because if your value, your p-value, is greater than 0.05, they are in fact equal. And so what that means is we're going to use the equal variances assumed row on top to get our information about t. And then we come over here. Oh, look at this. Very interesting and very sad. Making me cry. So t is negative 1.709. So remember, you want to report the t in your because it's a test statistic, you want to report the t in your lab report. So t is equal to negative 0.1709. But then let's look at the p. The p is what for this?
0.163.
0.163, that is correct. And do we have a difference between 15 and 25? No, we do not. And I am willing to bet anything that is because we have such a low sample size. Because there's a huge difference between 30 and 60. So we cry. So that means you do not make a graph there. I cry. You celebrate.